Hi everyone, in this video I'm going to introduce our RepVec fields accepted by ECCV 2024. We aim to handle multitask 3D perception more effectively with a unified representation. Autonomous driving systems need to perform many tasks simultaneously, which are complementary but often handled separately. For example, detecting objects like cars or pedestrians and identifying lane markings. Current approaches include standalone models or multi-head multitasking. Standalone models are task-specific, so they can't share features between tasks, resulting in wasted computational resources. Multi-head multitasking reduces this waste by sharing a backbone, but it creates another problem: task balancing. When different tasks compete for the same resources, it can lead to instability during training. We attribute the task competition to the variation in representation between different tasks. So we introduces a unified shared representation that aims to eliminate task competition. It can be converted into task-specific elements using differentiable transformations, meaning it can work with existing labels without any major modifications. To put this into action, we present RFTR, a single-head multitask framework. What's exciting about this is that RFTR eliminates task-specific parameters and doesn't require gradient calibration, which is often tricky when dealing with multiple tasks in deep learning. And finally, our unified framework achieved impressive performance in both 3D object detection and 3D lane detection. The insights behind RepVec fields are forward-thinking. We believe it's both possible and plausible to unify perception tasks. RepVec fields operates as a nesting of geometric structures that capture both the objects and the context around them, with point sets and vector fields defined on them. Moreover, it's task-agnostic, meaning the same representation can be used across different tasks, like detecting cars or identifying lanes. This makes it incredibly flexible and efficient, allowing us to easily convert it into task-specific outputs while maintaining consistency across tasks. In terms of training, the shared learning process not only simplifies the training pipeline, but also ensures that different tasks can benefit from shared improvements during training. In short, RepVec fields simplifies multitask perception, offering a unified way to handle complex driving environments. Now let's talk about how we implement RepVec fields in practice using the RFTR, or Representative Vector Fields Transformer. This is a single-head multitasking framework designed for 3D perception. The process begins by generating set-level perception queries. This involves encoding initial positions from the point level and then embedding them at the set level. RFTR's multitasking capability lies in its unified structure. It uses a single head to handle multiple tasks, with queries that are learnable and updated in decoder layers iteratively. The unified predictions generated by RFTR are then converted into task-specific representations for further supervision. One critical factor in ensuring effective multitasking is gradient balance. The success of a multitask model often depends on whether the gradient is balanced across different tasks. If we look at the results here, on the graph on the right, we can see the improvement RFTR offers. Compared to multi-head approaches, RFTR shows much lower gradient disparities, leading to more stable training. We use an improved measure of gradient disparity that takes into account the symmetry. What's interesting is that both the unified representation and the single-head design contributed about equally to this improvement in gradient balance. As shown in the two tables, our RFTR model showcases significant achievements in 3D lane detection, and the performance of our RFTR model in 3D object detection is comparable to its baseline and is promising. We have also conducted ablation studies to firstly find out how head designs and representations contribute to the performance, and we have also evaluated the effectiveness of different representations for 3D lane detection. This graph demonstrates the capability of RFTR to simultaneously achieve 3D lane detection and 3D object detection. The figure clearly illustrates that RFTR can accurately predict RepVec fields and perform both tasks at once. In summary, we argue that the imbalance of multitasking comes from the differences in task representations. We have proposed a unified vector field representation to bridge this discrepancy and have also proposed a single-head multitasking framework that eliminates task-specific parameters. Our approach mitigates the gradient imbalance of multitasking. We have achieved good performance across two key tasks in autonomous driving. RepVec fields not only improve system efficiency, but also pushes the boundaries of what's possible in autonomous driving. Thanks for watching. If you have any questions, please leave a comment below.